Hello everyone. In this video we'll be discussing calculations for curved mirror problems. So this relates to the ray diagrams that we have done in the past, but this time we can actually calculate where the object will be in comparison to the mirror, where the image will be, how tall the object is, or maybe how tall the image is. So there's a few different formulas that we can use to figure out the distance or maybe the height of either the object or the image. We can also figure out the focal length as well of the mirror. So the first equation we have, I'll just circle it here really quick. We have 1 over f equals 1 over dO plus 1 over di. So what the f stands for, we have our focal length. So 1 over the focal length equals 1 over dO. So what that dO stands for is the distance of object. So distance of the object, and that is from the mirror. So the distance of the object from the mirror. Finally, we also have 1 over di. So what di stands for is distance of the image from the mirror. So distance of the image and from the mirror. So both the dO and di, that's in comparison to the mirror. Okay, so that's one of our formulas that we can use. 1 over f equals 1 over dO plus 1 over di. The next two we have to do with magnification. Okay, so magnification is whether the image is larger or smaller than the object. So this first one here, we have magnification, which is m, equals negative di over dO. So we'll just quickly write down the m will stand for magnification. Cool. And our second formula here, we have m equals hi over ho. So what hi stands for is the height of the image. So the height of the image, and that would be from the principal axis to the top of the image. And then we also have ho. Sorry, I will put hi equals, and then we have ho equals the height of the object. So height of the object. So again, that's just the distance from the principal axis to the top of the object. So before we get into these examples, just a few notes to go over quickly. We have virtual image distances will always have negative values. So if the image is found on the opposite side of the mirror as the object, it'll have a negative value. Number 2, real image distances will have positive values. So if the image is found on the same side of the mirror as the object, it will have a positive value. Next up, we have a positive magnification and image heights will equal an upright image. So if it has a positive magnification, it means the image will have or will be upright. Okay. A negative magnification and image heights will equal a inverted image. So if the magnification or the image height is negative, the image will be inverted. And finally, probably the most important one here, diverging and convex mirrors. So remember, diverging and convex are the same thing. These types of mirrors will always have a negative focal length because it's found behind the mirror. So the focal length of a diverging mirror will always be negative because it's found on the opposite side compared to the object. So it's always found within the mirror. Okay, so example number 1, it says an object 7 centimeters high is placed 25 centimeters in front of a converging mirror with a focal length of 21 centimeters. What is the location of the image, magnification, and image height? So we have some values here. I'll just square off really quick. So it's 7 centimeters high, and it's 25 centimeters in front of a converging mirror. So the type of mirror is also quite important. Make sure to take note of that. And finally, the focal length is 21 centimeters. So we should also square that off as well, because that's relatively important. Okay, so we have 3 values and the type of mirror. We can work with this to answer these 3 questions here. So we need the location of the image, the magnification, and the image height. So first things first, we should write down exactly what we know. So we know the height of the object. So the height of the object is 7.0 centimeters. We also know the distance of the object. So we know DO, and that's 25.0 centimeters. And finally, we also know the focal point, or the focal length. And that is 21.0 centimeters, and it is a converging mirror, so that will be a positive value. Make sure we take note of that. Now the first thing we should solve for is the location of the image, so we can solve for DI. So the formula that we can start using is the mirror equation, which is 1 over F equals 1 over DO plus 1 over DI, except we need to manipulate a little bit because we eventually want to end up with DI. Okay, so first we'll just subtract 1 over DO from the right side as well as the left side. We'll end up with a new formula, 1 over F minus 1 over DO will equal 1 over DI. We can just input our variables here. So we have 1 over 21.0 centimeters, and that's subtract 1 over DO, which is 25 centimeters. That's going to equal 1 over DI. So if you type that into your calculator, you will get a value for 1 over DI of, let's just see here, 0.007619. So 7619. Except we want to have, let me just make a little bit more space here. There we go. And maybe just a little bit more. Okay, so we have 1 over DI, but we just want to have DI, so we need to take the inverse. We need to take the inverse of this number right here to figure out what DI is. So basically what happens is DI and this value here pretty much just switch places. So we'll have 1 over 0.007619 equals DI, and if you type that into your calculator, you will eventually get a DI of 131.25, and let's just take a look at how many sig figs we need here. Looks like we used 3, so we'll round to 3 really quick. I'm just going to make a little bit more space here. There we go. So we'll end up with a DI of 131 centimeters. So the distance of the image is 131 centimeters. So it looks something like that. We can add that to our values that we know. So we now know our DI is 131 centimeters. So the next thing we need to look for here is magnification. So we have a couple different equations we can use here, but I would like to start with something that I know at least two values for. So we have 4 values on our little sidebar here. And it looks like I need to use, I'm going to do it on the right side here, magnification equals negative DI over DO, because I have both of those values. I have DI and DO. So I can input these in. I have negative 131 centimeters. Make sure you keep this negative as it's part of the formula. That will play a part in your answer. And that is over 25.0 centimeters. And you'll get a magnification of negative 5.25. So with that value right there, we know because of the negative in the magnification, this is going to be a inverted image. So it's going to be upside down. Okay. We just have one more question to answer here, and that's the image height. And it looks like we're going to have to use the other magnification equation to figure that out. So let me just square off a little block here for us, make this a little bit neater. So we have magnification equals the height of the image over the height of the object, and we have 2 of the 3 values here. We have the HO as well as magnification. So we can manipulate to find our HI. So let's multiply out our HO. And our final equation that we're going to use is just M multiplied by HO will equal our HI. Let's put in our values. So we have negative 5.25 multiplied by HO. And that is just going to be 7 centimeters. Perfect. So 7 centimeters. And that is going to give us HI. And if you type that into your calculator with significant figures, because we do want to keep those, you should get a HI of just 37 centimeters. So that's our HI. So we have solved for everything we need there. Looks very good to me. Sig figs should be correct. Let's move on to number 2. So an object that is 10 centimeters high is put 13 centimeters in front of a diverging mirror with a focal length of 5 centimeters. Find the image location and the height. So this question is very similar. The main difference though is we have a diverging mirror, which is going to affect our focal length, right? Because diverging or convex mirrors will always have a negative focal length. So let's write down what we know. So we have an object that is 10 centimeters high. Okay, so that's going to be our HO. So 10.0 centimeters. We also have the DO, similar to last question. So that's going to be 13.0 centimeters. And we also have our focal length, which is going to be negative 5.0 centimeters. So the question here wants us to find the image location as well as the height. So we'll use a similar strategy to our first example here. So we'll start off with the mirror equation. So we just have 1 over f, and that is equal to 1 over dO plus 1 over di. So let's manipulate so we can eventually solve for di. We'll subtract 1 over dO over to the left side to give us 1 over f, subtract 1 over dO equals 1 over di, and let's input our values here. So 1 over the focal length, which is -5 centimeters, and that's subtract 1 over dO, which is 13.0 centimeters, and that's equal to 1 over di. So if we put this into our calculators here, folks, we'll get kind of an ugly looking number here. Make sure to keep this negative on our focal length. It is quite important. But 1 over di will equal 0.276973. We'll keep quite a few figures here because we have not found our answer yet. And if we take the inverse of this, remember we're always going to take the inverse here. So 1 over negative 0.276973. That's going to give us our di. So if you type in 1 over negative 0.276973, you should get a di of negative 3.6 centimeters with significant figures. And just make sure that's right. Yes, our focal length just has 2 sig figs, so that negative 3.6 should be good. So we have our di now. Perfect. So we can add to our little arsenal here of values. So negative 3.6 centimeters. I'll just cube this off so we have this. All right. So now the next thing we need to find is the image height. However, there's no formula that we can use right now that'll take us directly to image height. We must first find magnification like we did in the last example. So again, we will use m equals negative di over dO, since we have both di and dO now. So input our values here. We have negative, and since the di that we got was also negative, we have a double negative, which is a positive. So those negatives will cancel each other out, and we'll just end up with positive 3.6 centimeters over positive 13 centimeters. So our magnification is actually going to be a positive, and it's going to be 0.28. So our magnification is 0.28. Okay. So now that we have magnification, we can finally find the image height. So we'll use that last magnification equation that we can. We have m equals hi over ho. We need to manipulate just a little bit to solve for hi. So we'll multiply ho over. That'll cross out. So our final formula will just be magnification multiplied by ho equals hi. Fill in our values. So we have 0.28. Make sure you get your signs correct. And that's multiplied by ho, which is just 10.0 centimeters. That's going to give us our HI. If you type it into your calculator with significant figures, you should get a final HI of 2.8 centimeters. Okay, so notice our HI is positive. Okay, so that means we'll have an upright image. Our image will be right side up. Okay, so I can fill out the last of our information that we need. And notice how all my units are also correct. I have centimeters where I should have centimeters. Magnification will not have any type of unit. And that ends our video. I hope this has helped.